Hello scholars, welcome back to the Kemet Maasai Academy. What we're looking at today, we're combining area and rectangle, area and perimeter in one problem. So the problem says, draw and label 8 different rectangles that could have an area of 120 meters square. So we're going to come up with the dimensions, the length and width for 8 different rectangles that would have an area of 120 meters square, and we're going to calculate the perimeter of each rectangle. How will we go about doing that? Now the area of a rectangle, so let's write that so we don't forget. Area of rectangle, that's length times width. Okay? The area of a rectangle is the length times the width. So then we need to find out which 2 sets of numbers, or which 8 sets of numbers, when we multiply them we get 120 meters square, because one of the numbers would be the length and the other one would be the width. So we really need to find pairs of factors of 120 and draw them as rectangles, and then we're going to calculate the perimeter of these. So let's make a list of all the pairs of factors that multiply to give 120 meters square. Alright, so let's start with the first factor, which is 1. So that's 1 meter times what? 120 meters. Alright, 2 can go into 120, so that's 2 times 60. 3 can go into 120, so that's 3 times 3 to 12, 4, 3 times 40. 4 can go into 120, 4 into 12, 3, so 4 times 30. 5 can go into 120, 5 into 12, 2 times, remainder 2 and 5 into 24. 6 can go into 120, 6 into 12, 2 times, 6 into 0, 0. 10 can go into 120, 12 times, and what else can go? 15 can go into 120. How many times can 15 go into 120? So that will be, I think, 8 times. So 15, 8 into 12, 1 time remainder, 4, 8 into 45. So 15 times 8. Alright, so we have, they asked us for 8, so that's 1, 2, 3, 4, 5, 6, 7. 8 pairs of factors that when we multiply them we get 120 meters square. So that means the longest side would be the length and the shortest side would be the width. The 1 meter times 120, that's going to have a long length compared with the width. So that's going to be long 120 times 1. So that's 1 meter, 120 meters. Okay? 2 meters a little thicker, and 60. So 2 meters, 60 meters. 3 meters is getting thicker and thicker and shorter. 3 meters and 40 meters. 4 meters and 30 meters. 4 meters, 30 meters. 5 meters, 24 meters. Okay, 5 meters, 24 meters. 6 meters and 20 meters. 6 and 20. 10 and 12. 10 and 12. So that's 10, 12. And let's put the 15 by 8 over here. So 15 by 8. 15. Sorry, so this will be the 8. 8 and 15. Alright, so these are our rectangles. They're not drawn to scale, so they're nowhere near accurate, right? But a good representation of what they would look like: 1 by 120, 2 by 60, 3 by 40. The shorter side being the width, the longer side being the length. So now they want us to calculate the perimeter. So the perimeter of a rectangle, we already know the area for each of them would be 120 meters squared. That we know because they told us that, right? 2 times 60, that's 120. 1 times 120, that's 120. 3 times 40, so width times length. All these rectangles, all of them have an area of 120 meters square. The perimeters, however, will be much different. So the perimeter of a rectangle is 2 times the length plus 2 times the width. Or we could just add the distance around the edge, right? We have 2 widths that are the same, 2 lengths that are the same. So 2 times the length plus 2 times the width. So even though all these rectangles have the same area, 120 meters square, each one will have a different perimeter. So let's work the perimeter of each one. So that is 2 times 120 plus 2 times 1. So that's 240 plus 2. So the perimeter for this rectangle is 242 meters. 2 times the length, 2 times 120 is 240. 2 times the width, 2 times 1, 2. The perimeter of this one, 2 times the length plus 2 times the width. So 2 times 60, that's 120, and 2 2s 4. So this perimeter is 124 meters. Okay? Same area, they have the same area, different perimeter. The perimeter of this rectangle, 2 times the length plus 2 times the width. So that's 2 times 24, 48, 2 5s 10. So the perimeter is 58 meters. So much difference in the perimeters, even though they have the same area. The perimeter of this rectangle, 2 times the length plus 2 times the width. So 2 times 40, that's 80, 2 3 is 6. So this is 86 meters. Perimeter of this one, 2 times the length plus 2 times the width. So that's 60 plus 8, that's 68 meters. You notice none of them so far have the same perimeter, they're all different, even though they all have 120 meters square as the area. Alright, how about this one? Perimeter, 2 times the length plus 2 times the width. So that's 2 times 20 is 40, 2 6 is 12. So the perimeter here is 52 meters, close to this one. So the 5 by 24 is pretty close to the 6 by 20. These two are also close, the 3 by 40 and the 4 by 30. Their perimeter is close enough. Alright, for this one, 2 times the length plus 2 times the width. So that gives 2 12s 24, 2 10s 20. So the perimeter is 44 meters. None of them the same so far. Here, perimeter is 2 times the length plus 2 times the width. So that's 30. 2 times 15 is 30 plus 2 is 16. So the perimeter is 46 meters. So what we have, each of these rectangles has a perimeter that is different from the other. 8 different rectangles, all of them have an area of 120 meters square. So the first thing we did was we found what pairs of numbers, what pairs of factors can we list that would multiply to give 120, because we know the area of a rectangle is the length times the width. So we're saying if we find pairs of factors, the biggest one could be the length, the shortest one could be the width. And we simply just need to make sure that when you multiply them, you get 120. So these are the pairs of factors we got. 1 times 120, 2 times 60, 3 times 40, 4 times 30, 5 times 24, 6 times 20, 10 times 12, 15 times 8. They all multiply to give 120 meters square. But what we found when we drew these rectangles and we were asked to find the perimeter of each one, remembering that the perimeter of a rectangle is 2 times the length plus 2 times the width. Mark, we could have added all the distance around. We could have said 1 plus 1 plus 120 plus 120. We would have gotten the 242, or 2 plus 2 plus 60 plus 60. But at the more advanced level now, we're expected to know 2 times the length plus 2 times the width, and that's what we did. For all these rectangles, we multiplied the length by 2 and the width by 2 and added them together, and we found that none of them have the same perimeter. The perimeter for this one, 242 meters, 124 meters, 58 meters, 52 meters, 86 meters, 68 meters, 44 meters, 46 meters. Some came pretty close. Some came pretty close to each other, but none having the same perimeter. So that shows us that rectangles, several of them can have the same area, but the perimeter will more than likely be the same. So you can do your own experiments at home, right? Think of a number. Let's say 100. Let's say number 100. How many rectangles can you think of that where you multiply the length by the width, you would end up with 100 meters square or centimeters square? And you don't have to stick to whole number factors. You can throw in some decimals, throw in some fractions. Once they multiply to give 100 in the end, you can throw those in as well, right? And then multiply the width by 2 and the length by 2 and add them and see what you get for the perimeter and compare them and see if you find any two that have the same perimeter. I'm thinking you will not. Okay, but try it for yourself. As a scholar of mathematics, you need to test these things out by yourself. Alright? So that's it for combination of area and perimeter. We just wanted to demonstrate, this activity was to demonstrate that rectangles having the same area have different perimeters. Alright, so if you have benefited from this video, just drop a line in the comments to say thank you. And I'm going to ask you to share the video, because that's the whole point of doing these videos, to get the information out there so students can know that math is wonderful, math is lovely, math is delicious. Alright, so we all can learn to do math. Now let me know in the comments also if you want me to do a video on any particular topic. And of course, if you don't see the topic you've been looking for, let me know and I'll do that video for you. So scholars, take care, keep practicing your maths every day, every single day. Practice, practice. I'll see you in the next video.